Hey folks, Shubh here from Mentor for You. So I'm back with the second part of the quadratic equation, for the A-level maths. So in the last part, we discussed that how to find the roots of the quadratic equation by the factorization technique. In this video, in this part of the quadratic equation, we will be discussing how to solve the quadratic equation by the quadratic formula. Well, actually, quadratic formula is a simple formula. Like just by using that formula, we can directly get the roots, right? So we don't have to worry about factorization or we have to take the roots directly from the, we can find the roots directly by using the formula. So let's start with this. For example, let's say we have a general quadratic equation as ax square plus bx plus c, where a is the coefficient of x square, b is the coefficient of x, and c is the constant of a quadratic equation. Like every quadratic equation have a x square term, x term, and a constant term. They are like a, b, c are basically the coefficient respectively. So if that is the quadratic equation, then the roots are going to be minus b plus and minus root of b square minus 4ac divided by 2a, like whole divided by 2a. Like since it's a quadratic equation, there will we will have two roots. Like that plus and minus basically defines that we have two roots. So one of the root is minus b plus root of b square minus 4ac divided by 2a, and the other root is just the opposite of it, like the conjugate of it. So minus b minus root of b square minus 4ac divided by 2a. So what is the use of taking this formula into account? See, there can be fractional roots, there can be irrational roots. Now we cannot find them just by factorizing them. Like we cannot factorize irrational term, right? That's the reason of using this formula directly, so that even if the factors are irrational or fractional, we can easily calculate them. All right, let's take some question. So here we have a quadratic equation as 4x square minus 4x minus 1. You can easily point what is going to be a. A will be 4, b will be minus 4, and c will be the constant which is minus 1. If we directly use the formula as minus b plus minus root of b square minus 4ac divided by 2a, we can get the roots, right? So here for this quadratic equation, the roots will be minus b. B is minus 4, so minus of minus 4 plus minus root of b square, which is minus 4 whole squared, minus 4 multiplied by a is 4 and c is minus 1 divided by 2 multiplied by 4, right? So that is going to be 4 plus minus root of, I think that's 16 plus 16, that will be 32 divided by 8. Or you can simplify this further as root 32, we can write it as, I think it will be 2 root 8, right? Or fine, you can just leave it like that. It is going to be 4 plus root 32 divided by 8 and 4 minus root 32 divided by 8, right? So whenever we have a quadratic equation where the roots are irrational, we can use this formula to get the roots, right? Similarly, for the second question, we have a as 6, b as 13. We can just write that a is 6, b is 13, and c is minus 5. So again we can use that formula, minus 13 minus b plus minus root of b square, which is 13 square, minus 4 multiplied by 6 multiplied by minus 5 divided by 2 multiplied by 6, 2 multiplied by 8. So 13 square is 169 plus, I think that's 34 will be 120, and that will be 289 minus 13 plus minus root of 289 divided by 12. I think root of 289 is going to be 17. So the roots are basically going to be minus 13 plus 17 divided by 12 and minus 13 minus 17 divided by 12. And how much is that? 4 divided by 12 will be like 1 by 3. And that's 30 divided by 12. 10 divided by 4. So these will be the roots for this quadratic equation. Similarly, you can try this one out and you can put your roots, your solutions in the comment section. I'll be reviewing that and I'll let you know if they are correct or not. Alright. Similarly, here we have some more quadratic equations which we can find the roots. For example, here for this, the first question, we don't have to use the quadratic formula to find the roots. We can directly simultaneously solve them. For example, here we have 2x plus 8 whole square as 10. If I take root both the sides, that will be 10, right? That is going to be 10, or even that can be minus 10. Both the answers are correct. It can be 10 or it can be minus 10. So here 2x will be you take that 8 to that side, that will be 2. So x will be equal to 1. Similarly here, if you take that 8 to that side, 2x will be equal to minus 18. So x is going to be minus 9. Okay, these two are the roots for this quadratic equation. Similarly here we have 6x squared. So it doesn't look like a quadratic equation. So you have to first make it quadratic equation by taking that 12 to the left hand side. So that will be 6x squared minus 12x plus 6 equals to 0. Now we can solve them just by using the we can either factorize it or we can use the quadratic formula to do so. So here it will be minus of minus 12. I'm using the formula plus minus root of b square, which will be 12 whole square, minus 4 multiplied by, I think that will be 6 multiplied by 6 divided by 2 multiplied by 6. I think 12 square is 144 and 6 multiplied by 6 multiplied by 4 is also 144. So they will cancel out. It will be 0. So we have minus 12 divided by 12, which is minus 1. So don't worry about how we are getting a single root. The thing is that quadratic equations can also have repeated roots, right? So both the roots are going to be minus 1 and minus 1. Right? We'll talk more about that in details when we talk about the discriminant, what is a discriminant and how the value of discriminant depend on the number of roots, right? Next, we have a pseudo quadratic equation. We also discussed about what's a pseudo quadratic equation in our last video. You can go and check. So let me just give you a small recap of what's a pseudo quadratic equation. The name defines the whole thing. It looked like that it is not a quadratic equation, but it is a quadratic equation. So we have to first bring that equation in the form of a quadratic equation. Then we either factorize it or we use the quadratic formula to find the roots of it, right? So for example, here if you see, if I square both the sides, for when you see this for the first instant, it doesn't look like that it is like a quadratic equation. So what you can do is you can square both the sides. So that is going to be x square is equal to 8x minus 15. Now I think it's a quadratic equation. So what you can do is you can take that 8x and 15 to one side. So it is going to be x square minus 8x plus 15 is going to be 0. Now you can either factorize it or you can use the factorization, the quadratic formula to get the roots of it. So let's, like, since we are discussing about the quadratic formula, let's try it. So here A is 1, B is -8, and C is 15. And the formula is minus B, minus of -8 plus minus root of B square. B is -8. So that is going to be -8 whole squared minus 4 multiplied by A multiplied by A is 1 and C is 15. A multiplied by C divided by 2 multiplied by 1. That's it. So that will be 8. Minus of -8 will be 8 plus minus root of, how much is that? 64 minus 60, that is going to be 4 divided by 2. So here root 4 is going to be 2. So it will be 8 plus 2 divided by 2 and 8 minus 2 divided by 2. So 8 plus 2 is 10. 10 by 2 is 5. And 4, 8 minus 2 is 6. 6 divided by 2 is 3. So these two are the roots of the quadratic equation, right, for this particular quadratic equation. Now the next method of finding the roots is by the completing the square technique. Now we both know that, we all know that whenever we have a quadratic equation in this form, like x plus 2 whole square, or fine, x plus 2 whole square is equal to 10 or 100. In this form, like you can see that it is in the square form. Now in this case, it's easy for us to calculate the roots. Right? What we will do simply is we'll take that root on both the sides. So it is going to be plus 10 and minus 10. So x is going to be like some 8 and minus 12, I guess. Right? Like this is just an example. The motive here is, if we can represent any quadratic equation as a complete square, then it is very easy for us to calculate the roots of it. How? Let us learn how to find the complete square first, right? So whenever we have any quadratic form as like x square plus bx, let us first learn like how to make a complete square, then we will learn how to find the roots using that method. So whenever we have x square plus bx, what we should add to that term so that it becomes a perfect square is that we all know that a plus b whole squared is equal to a squared plus 2ab plus b squared, right? Similarly, using that concept over here, we have an x squared term, right? And this is some linear term, b multiplied by x. So what I'm trying to do is I'm trying to write that expression as a whole square of a plus b. Similarly, what I did here is I multiplied that 2 and divided that 2 over there, like just to bring that 2ab form over there. Right, now you can clearly see that we have a b by 2 term, we have a x term, x square is already there, but what is not with us is that b by 2 whole square term, which is b square by 4. So what we will do is we will add that and we will subtract that, right? So it is still the same as x square plus bx, right? You can see that x square plus bx is same as x square plus 2 multiplied by b by 2 multiplied by x plus b square by 4 minus b square by 4. And we know that what is this is the expansion of x plus b by 2 whole squared, right? And over here we have minus b by 2 whole squared, right? That's it. So to add, so we have to add b square by 4 to get a complete square right here, right? If we have this term x square plus bx, to make it a perfect square, we need to add b by 2 whole square. That's it, right? So let us take some examples like that. So here, to make this expressions a perfect square, we need to add something or we need to subtract something. Let us learn that concept here. Here, the motive is not to find the factors of this equations. Here, the motive is to how to make these equations a perfect square, right? So here, we all know that the expansion of a plus b whole squared is equal to a squared plus 2ab plus b squared. Now if you look into this equation, you can notice one thing, that this a square is reflected as a here and this b square is reflected as b here. So while making a perfect square or completing the square of expression, we should keep this concept in the mind, that we should bring that a and b's in the middle, or we can bring that b square term. So here if you see that we have uh, example here as x square plus 4x. If we try to factorize that, if we try to find the make it a complete square, what we can do is we can break that x square, break that 4x as 2 multiplied by 2 multiplied by x, and now you can see that this x square is reflected here as x and this 2 is also there, so that 2 must be reflected as 4 as 2 squared. So to make it perfect square, we must add a 2 square. Now since we are adding a 2 square, to balance it we must subtract that also, so we'll take that 2 squared also out. Right, now we know that this is the expansion of x plus 2 whole squared, so we can write that x square plus 4x as x plus 2 whole squared minus 4. Now to make that x square plus 4x a perfect square, which will be x plus 2 whole square, we must take this 4 out, right? So what we can do is we can take that 4 to the left hand side. So it will be x square plus 4x, which is the expression that we have. If we add 4 to it, it will become x plus 2 whole squared. So that's a perfect square. So this is how we make an equation a complete square, right? We can take one more example here. Let's say we have 5x squared plus 20, and if we try to break it as root 5 multiplied by x whole squared, and again we break that 20x as 2ab, which will be 2 multiplied by, we know that we have a here which is root 5 multiplied by x, right? And you tell me what we should multiply here to make it 20x. So here we have 2 multiplied by root 5x. So to make it a perfect square, we should again have another 2 root 5 multiplied by 2 root 5, right? Sorry, not multiplied, like it's same as 20x only, right? So 2 root 5 multiplied by x multiplied by 2 root 5. This you can see that root 5x is reflected here. So what we should add? We should add and subtract 2 root 5 whole squared, right? So that will be 2 root 5 whole squared minus 2 root 5 whole squared. And what is the value of 2 root 5 whole squared? That will be 4 multiplied by 5, which is 20, right? So you can see that this complete thing is the expansion of root 5x plus 2 root 5 whole squared. 5x square plus 20x is equal to this, and also we have root 2 multiplied by 5 whole square. Now to make it a perfect square, we should take this 2 root 5 out, right? We should add that 2 root 5 whole square or 20 on both the sides to make that expression 5x square plus 20x as a perfect square. So the next one, you can take it as a like work for you, right? You can try that and you can comment your answers in the comment section and I'll get back to you. Okay, I'll respond that. Next thing that we have here is we need to make this expressions a perfect square by writing it in this particular form, right? So what we can do is we can bring the same concept over here. We can take that make it a perfect square, we should bring that 2 multiplied by a multiplied by b. So what you can do is you can take these questions as homework, right? You can comment your answers in the comment section. I will personally comment back to all the students, those who comment. So all right, that's all about today's session. Thank you for watching this video. Stay tuned for more such content. Thank you.